Good morning everyone, I'm Cristian Grasso. I'm an assistant professor at the Department of Electrical, Electronic and Computer Engineering of the University of Catania. In this video I will present the activities carried out within the WatchEDGE project by the EMIP Aerial Monitoring Image Processing Laboratory, of which I'm a member together with my colleagues Professor Giovanni Schembra and the PhD student Andrea Caruso. The WatchEDGE project aims to develop automatic environmental monitoring systems based on the use of artificial intelligence to monitor and preserve not only animals, but also the habitat where they live. To achieve this, the activities of our group within the project can be summarized in 5 points. Automatic creation of aerial dataset and subsequent aerial recognition of animals and plants, thermal analysis, multispectral analysis, and photogrammetric reconstruction. To carry out these activities, we used a fleet of UAVs available in our laboratory. In particular, we have 4 DJI Mini 3 Pro used as sensing UAVs for image and video capture, a DJI Mavic 3 Pro with an RGB camera with higher resolution compared to the previous drones, a DJI Mavic 3M characterized by an integrated multispectral camera in addition to the RGB camera, and finally we have 3 DJI Matrice 350 RTK UAVs capable of carrying an additional payload of up to 2.7 kilograms. For the image and video capture, in addition to the integrated cameras of the UAVs, we used a DJI Zemius L2 camera equipped with LiDAR technology, which allow the possibility to implement photogrammetry, a DJI Zemius H30T thermal camera, and a Megasense RedEdge 3M multispectral camera. These cameras, mounted on board the DJI Matrice 350 RTK, allow us to expand the analysis that can be carried out during the UAV flights over the area of interest. In particular, in the Emiliano San Rossore Massaciuccoli Park near Pisa, in Italy, chosen as the project's experimental area. Regarding the first 2 activities, so the creation of the aerial dataset and the aerial recognition phase, several animals present in the park were considered. For example, the wild boars, fellow deer, wolves, horses, and the mucco pisano. But we also decide to evaluate the possibility to create a dataset regarding the vegetation. For example, the pine tree in the area, some of which are affected by the Cocciniglia tartaruga, as well as other medicinal species found in the Lame area of the park. To do this, we implemented a system that, upon receiving the video in real time coming from the UAVs during the mission, reduces its resolution depending on the bandwidth available on the channel between the UAVs and the ground server, improves its quality by removing possible noise, and extracts frame. These frames are then sent to an application deployed in the ground server that uses YOLO-E. YOLO-E is a semantic recognition algorithm that is able to create a dataset with the images of the subject of interest. This dataset, in the second phase, is used to train a recognition model for a specific class of individual. So we can create a model that is able to recognize white boars, another for fellow deer, and so on. These models are lighter than the YOLO-E based one and can be executed on Raspberry Pi or Jetson Nano mounted on board the UAVs. In this way, we can perform the inference phase during the missions of the UAVs. We can recognize spaces, count the individuals, and study their behavior. The result of this activity lead, in the case of the whiteboard, in the possibility to recognize and count them as shown in the video. As already said, another activity involves thermal analysis using the DJI Zemius H30T camera that allow us to perform not only night missions within the park, since animals can be identified by their body temperature, which is clearly different from the surrounding environment, but also to understand if some individuals show anomalies compared to the other, for example, if they have a higher or lower temperature than the average of other animals of the same species. Other analysis regarded the use of multispectral cameras. This type of analysis make it possible to evaluate the healthy status of vegetation thanks to the possibility to capture not only images in the visible range, the classic RGB, but also in frequencies that are not visible to the human eyes, such as red edge and near infrared range. Evaluating some parameters calculated using software like DJI Terra, it is possible to detect whether a plant that appears healthy may actually have problems that have not yet manifested. Finally, we also carried out photogrammetry missions for 3D reconstruction by capturing photos and generating point clouds using the DJI Zemius L2 camera, with the goal of identifying specific features of a particular area of the park, features that may not be visible except from an aerial view, studying the terrain and vegetation height variations, and even creating 3D virtual reconstructions of building within the park, as shown in the video.